There's a place at the bottom of the Atlantic Ocean, 4,000 meters beneath the surface, where the sun has never reached and where total darkness has reigned for over a century. In that darkness, resting on the ocean floor in two enormous broken pieces, lies the wreck of the most famous ship ever built, the RMS Titanic. A vessel that was called unsinkable by the people who built it, by the press that celebrated it, and by the passengers who boarded it with complete confidence on the 10th of April 1912. A ship so large, so technologically advanced, so thoroughly modern that the idea of it failing seemed almost philosophically impossible. And yet, on the night of the 14th of April 1912, 700 kilometers from the coast of Newfoundland, Canada, in the middle of a dark and freezing Atlantic Ocean, it failed. It struck an iceberg. It filled with water, and within 2 hours and 40 minutes it dragged 1,500 human beings down into the darkness with it. What the survivors told investigators in the immediate aftermath of the disaster seemed clear enough. The iceberg had torn a 300-foot gash along the right side of the hull. The damage was catastrophic and immediate. The ship sank. The story was complete, but the story was not complete. Because when researchers finally found the wreck 73 years later and began the slow painstaking work of examining what actually lay on the ocean floor, they discovered something that changed everything, that your world thought it understood about the most famous maritime disaster in history. Welcome to World Unveiled. These are the unsolved mysteries of the Titanic shipwreck. The search for the Titanic was one of the longest and most determined searches in the history of ocean exploration. For 7 decades after the sinking, the wreck lay completely undiscovered, its exact location unknown, its condition a matter of pure speculation, its secrets locked 4 kilometers beneath the surface in conditions of total darkness, crushing pressure, and near-freezing temperatures. Every year that passed, without discovery made the mystery deepen. Every expedition that failed to find the wreck added to the sense that the ocean was actively protecting its most famous secret. Then, in 1998, titled 5, a joint American-French research team led by oceanographer Robert Ballard finally located the wreck using advanced underwater scanning technology. The discovery was extraordinary. The Titanic was real. It was there. And the world was about to discover that the story it had believed for 73 years was not entirely accurate. Because the first thing researchers noticed, the thing that immediately created a new layer of mystery rather than resolve and the old ones, was that the ship was in 2 pieces, separated. The bow section and the stern section were not together. They were not even close to each other. They lay approximately 2,000 feet apart on the ocean floor, and the condition of the 2 sections was dramatically, almost inexplicably different from each other. The bow, the front section of the ship, was remarkably well preserved considering it had spent over 7 decades at the bottom of the ocean. Its shape was largely intact. Its structure was recognizable. Its portholes, its anchor chains, its railings, all visible, all identifiable, all maintaining something close to their original form despite a century of submersion in salt water 4 kilometers beneath the surface. Researchers could look at the bow and still recognize the Titanic, but the stern, the rear section, was a completely different story. The stern was devastated. Its decks had collapsed into each other, like a crushed tin can. Its steel had buckled and folded and compressed in ways that made the original structure almost unrecognizable. Parts had been flung outward and were scattered across the ocean floor in a debris field, stretching across more than 3 square kilometers. More than 10,000 individual objects. E-cups, dinner plates, crystal chandeliers, deck benches, personal belongings of the passengers, were spread across this enormous area on the ocean floor. And the stern itself sat 2,000 feet away from the bow, separated by a distance so significant that researchers immediately understood something dramatic and violent had happened. To these 2 sections of the same ship that could not be fully explained by the simple story of a ship striking an iceberg and sinking. The first mystery that demanded resolution was the 300-foot gash. For 73 years, the accepted explanation for how the Titanic sank was that the iceberg had torn a massive 300 foot-hole along the right side of the hull. A wound so catastrophic that the ship's fate was sealed from the moment of impact. But when researchers and ours began examining the actual wreck site in detail, something extraordinary emerged. The 300-foot gash did not exist. Despite dozens of expeditions to the wreck site, despite the fact that oceanic explorer Paul-Henri Nargeolet visited the Titanic wreck more than 30 times over the course of his career, nobody ever found evidence of a 300-foot tear in the hull. The damage that was found was far smaller, far less dramatic, and yet in some ways more scientifically interesting than a simple massive tear. What researchers identified was a series of narrow cracks and separations in the hull plates along the right side of the bow section, damage covering an area of approximately 30 feet, with an opening estimated at around 11 square feet in total. 11 square feet, not 300 effects. Ette of open hull. A crack. A series of separations between steel plates that had been forced apart by the eye impact with the iceberg rather than torn through by it. When engineers ran the calculations on what an 11 square foot opening would mean for a ship the size of the Titanic, the mathematics produced a number that aligned perfectly with what the eyewitnesses had reported. An opening of that size would allow approximately 370 gallons of seawater to pour into the ship every single second. At that rate, the ship would fill completely with water in approximately 2.5 hours. And the eyewitnesses, the survivors who had watched the Titanic sink from lifeboats in the freezing Atlantic, had consistently reported that it took the ship approximately 2.5 hours to go under. The mathematics matched the testimony precisely. The mystery of the sinking time was solved, but an entirely new question had opened up to replace it. If the damage to the Titanic was a relatively narrow crack rather than a massive 300-foot gash, why did the steel plates fail in that way? Why did the hull separate rather than simply being torn through? The answer to that question lies in the metallurgy of the steel used to build the Titanic, and it reveals a deeply troubling truth about the ship's construction. Modern analysis of steel samples recovered from the Titanic wreck has shown that the steel used in the hull was of significantly lower quality than the steel that would be used to build a comparable vessel today. The specific problem was the steel's brittleness in extremely cold water. At the temperatures of the North Atlantic on the night of the 14th of April 1912, water temperatures hovering just above freezing, the steel in the Titanic's hull became dramatically less flexible and far more prone to fracturing than it would have been in warmer conditions. When the iceberg struck, instead of bending and absorbing the impact as modern high-quality steel would do, the hull plates fractured along their edges. The rivets, the steel pins holding the H-hull plates together, popped under the stress of impact, allowing water to pour through the gaps between plates rather than through a single clean gash. The Titanic was sunk not by a single catastrophic woe, but by the failure of thousands of individual connection points along its hull, driven by steel that simply was not strong enough to survive the conditions it encountered. The ship W as not unsinkable. It was, in some fundamental sense, underbuilt for the environment in which it was operating. The mystery of why the bow and stern ended up in such dramatically different conditions, and why they landed 2T, how sand feet apart, was eventually solved through one of the most extraordinary applications of technology ever applied to a historical investigation. Using high-technology sonar scanning equipment combined with remotely operated underwater vehicles, researchers captured hundreds of thousands of photographs of the entire Titanic wreck site. These photographs were then processed using computer graphics to create a complete, detailed three-dimensional model of the wreck and its surrounding debris field. The resulting model revealed details that no human eye could ever have seen directly and that no conventional CA mirror could ever have captured at that depth and in that darkness. And what the model showed about the final moments of the Titanic's sinking was both scientifically fascinating and deeply soul-bearing. When the bow section flooded and began to sink, the enormous weight of the water-filled front of the ship began pulling downward while the stern, still containing air pockets that were keeping it temporarily buoyant, remained paths, archly above the surface. The center of the ship became the pivot point for these two massively different for CES, the bow pulling down, the stern floating up, the structural steel at the center bearing a load it was never designed to sustain. Even, tually, catastrophically, the center broke. The ship separated into two pieces, but the three-dimensional model revealed something that completely changed the accepted understanding of when and how the separation occurred. For years, it had been believed that the ship broke apart at the surface, that eyewitnesses had watched the two sections separate above the water before both sank. But the debris field tells a different story. More than 90% of the objects scattered across the ocean floor belonged to the stern section. And if the stern had broken apart above the surface, the forces of that open-air separation would have scattered debris across a far larger area than the 3.2 square kilometers where it was actually found. The debris field was too concentrated, too contained, which means the stern did not fully break apart above the water. It separated from the bow at or near the surface. But the catastrophic structural collapse that produced the compressed, flattened, devastated condition of the stern section happened when it hit the ocean floor. The three-dimensional sonar model showed the unmistakable impression marks left in the sediment by the stern when it struck the bottom. Those marks showed the stern was rotating in an anti-clockwise direction. And calculations based on those marks indicated that the stern was traveling at approximately 80 kilometers per hour when it hit the ocean floor 4 kilometers below the surface. At that speed, hitting an immovable surface, the forces generated were enough to collapse every deck into the one belos. WIT, to compress the entire rear section of one of the largest ships ever built into a crumpled mass of steel, and to scatter its contents across kilometers of ocean floor. The bow, by contrast, had a hydrodynamic shape, designed specifically to cut through water cleanly, and descended to the bottom in a far more controlled manner, which is why it survived in far better condition than its shattered counterpart. Today, the Titanic is disappearing. The bacteria that colonize the steel of the wreck, consuming the iron and producing the distinctive rust formations that cover every surface, are dismantling the ship at a rate that scientists find both fascinating and deeply sad. In the low oxygen environment 4 kilometers below the surface, the rusting process happens far more slowly than it would above water. But it is happening. The rust formations are consuming the steel. The structure is weakening. Deck by deck, section by section, the Titanic is slowly collapsing into itself. Scientists estimate that within the coming decades, the wreck will lose its recognizable shape entirely. The ship, which was called unsinkable, will finally, completely, irreversibly disappear into the ocean floor that has held it for more than a century. The mysteries it has already answered, the true nature of the hull damage, the metallurgical failures of its steel, the extraordinary forces that produced 2 such dramatically different wreck sections, the precise sequence of its final minutes, are permanently part of the scientific record. But the ocean keeps its secrets slowly and incompletely. The Titanic still holds questions that may never be fully answered. About the exact decisions made on the bridge in the minutes before impact. About what the 1,500 people who died that night experienced in those final 2.5 hours. About whether different decisions, different materials, different choices could have changed the outcome of that April night in 1912. The ship is still telling its story, and the ocean is still listening. Welcome to World Unveiled. Some mysteries are solved by science, and some are kept forever by the deep.